Hey there. I'm making a video tonight for our homework, which this distributive property that we were learning yesterday and today can be a little tricky for kids to understand. So I wanted to make sure that there wasn't any kind of frustration going on at home and that you had all the tools that you needed to help with homework tonight. So if we take a look at this, another look, that kind of explains what we've been doing in class. The array below, which is our big array, shows 6 rows times 4. So 6 rows, they count 1, 2, 3, 4, 5, 6, with 4 in each row. 1, 2, 3, 4. That's how we get that 6 times 4 array. So you can draw a line to break 6 rows of 4 circles into 2 rows of 4 circles and 4 rows of 4 circles. So you can see they took this big array, broke it into 2 smaller arrays over here, and then each new array has a new equation. 2 times 4, 2 rows of 4, times or plus 4 times 4, which is 4 rows with 4 in it. So as the kids get working tonight, in 1 and 2, they've drawn arrays for you, and they ask you to separate them into 2 smaller arrays. So we found in class today that when we have an array with 4 rows, that it's nice to split them into a doubles problem, 2 rows plus 2 rows. So then this top piece of the array gets a new equation, and it is 2 rows with 3 in each row, 2 times 3. And the bottom one also gets a new array, 2 rows with 3 in each row. Now, when I have been teaching them how to write the equation for a distributive property, we've got 4 plus 3. The 4 is what we split. 4 rows got split into a 2 plus 2. So I put my 2 here for the first array. There's my plus sign, and there's my 2 for the second array. The 3 in each row did not change. So that's going to stay the same in both of these new equations. 3 in each row. So 2 rows with 3 in each row plus 2 rows with 3 in each row. If they want to solve that, then we would do the parentheses first. 2 times 3 equals 6, plus, that stays the same, 2 times 3 equals 6, 6 plus 6 equals 12. So now we know that 4 times 3 equals 12. In the next array, we have 5 times 6. We can split this one any way we want, but if I wanted to split it here, I could. Now, we split it across the rows last time. This time we're splitting across the columns, and that's okay. What I would do is I would write a new equation for the first side of the array. This one is 1, 2, 3, 4, 5 rows with 3 in each row. And this one is also 5 rows with 3 in each row. So my new arrays equations come down here. My 5 rows did not change, so I keep that in both equations. Then the 6 did change. I split it into a 3 plus 3 equation. So my first 3 goes here, here's the plus sign, and the second 3 goes here. 3 in the first array, 3 in the second array. To solve that, I would do 5 times 3. We've been learning count by 5s, and today we learned count by 3s. So 5, 10, 15, plus 15. They don't need to solve that, but if they'd like to, they could. 15 plus 15 equals 30 in all. Now, down in 3 through 10, it just is asking us to use the distributive property. And so in this case, I have to look and see, I've got 4 rows with 6 in each row in my first equation, my first array. I notice over here my first array, or like my first expression here, is a 1 times 6. Well, I notice the times 6 stayed the same, but 4 broke into 1 row instead of 4 rows. So that means that I would have 3 rows in an array left. So I know that this one is going to be 3. 1 plus 3 equals 4. The times 6 stayed the same in both new expressions. in number 4, I've got 5 times 8. I notice in both of these new equations or expressions, I've got a times 8. So the times 8 stayed the same. So I'm looking at this 5 and deciding in an array how many rows would be broken off. I know I have 2 rows times 8 in this array. So that would mean that I would have to go 5 subtract 2, which would leave 3 rows left. So this other array in my mind would have 3 rows with 8 in each row and 2 rows with 8 in each row. I hope that makes a little bit of sense. You could also have the kids draw an array. Graph paper works best. For that, we've been drawing arrays in class as well to kind of help them understand that we are taking a whole array, splitting it into 2 parts, and then adding them back together to help solve. 4 times 5, I notice that this first expression has a times 5. The second expression has a 2 times something. Because this has my times 5, this one's also going to have a times 5. That doesn't change. So because this 4 is what's being broken, my rows of 4, I'm going to see that has 2 rows in this side, and so this one has to have 2. 2 plus 2 equals 4. In 6, I have 7 times 6. I notice I've got 3 times something plus something times something. 7 subtracted by 3 would put my 4 here. 3 plus 4 equals 7. The times 6 has to stay the same. I cannot break an array both ways. And so that means that one side has to stay the same. If it's the 5 rows or the 6 in each row, but something has to stay the same. 3 times 8. In this case, my times 8 is staying the same. 8 in each row. I've got 3 that is being broken. I broke 2 rows off, so I have 1 row left. 5 times 7. My times 7 is going to stay the same. 4 times 7. I notice I've got 2 here, so I can only have a 2 here. 2 plus 2 equals 4. The times 7 stays the same. And then 5 times 5 equals something. I notice I've got a 4 here. 4 rows got broken off, which leaves 1 by itself. And my times 5 stayed the same, or 5 in each row. On the back side, let me adjust my camera. There we go. On the back side, it says use structure. Tony broke a larger array into a 2 times 3 array and a 4 times 3 array. What did the larger array look like? Okay, so I know that the times 3, or 3 in each row, stays the same. I have 2 rows times 3, and I have 4 rows times 3. So Tony would have split his array right here. But if I put it all back together, I count that he has 1, 2, 3, 4, 5, 6 rows in all, which makes sense. 2 plus 4 equals 6, with 3 in each row. So that takes care of draw a picture. Write an equation to show the relationship between the larger array and the 2 smaller arrays. So here is my larger array. It's going to be equal to the 2 smaller arrays added together. So I take my 2 times 3. I add it to my 4 times 3. And to make math easier, we put parentheses around the expressions that need to be done first. So that would take care of our write an equation to show the relationship between the larger array and the 2 smaller arrays. If they'd like to solve it, we do these first. 6 plus 12, which equals 18. Okay, with higher order thinking, Rosa says she can break this array into 3 different sets of 2 smaller arrays. Is Rosa correct? Yes. The answer here is yes. She could split it like this. Here and here. And her big array, 1, 2, 3, 4, 5, 6 rows times 1, 2, 3, 4, 5, 6, 7, 8, with 8 in each row. And then we would just add all 3 equations. So this new one is a 2 times 8 plus a 2 times 8 plus a 2 times 8. As long as they are splitting rows together like this, rather than rows plus columns. We cannot split rows and columns on the same array, but we can split rows as many times as we need to, such as that, and get the same answer. So 6 times 8 would be 16 plus 16 plus 16, which would equal 48. Use the distributive property. Make sure you're in the camera. Use the distributive property. Which of the following expressions are equivalent to 7 times 6? Select all that apply. Okay, so what we're going to look at here, make sure first we've got multiplication in both of our parentheses with a plus sign in the middle. This would have to equal either 12 times 7 or 6 times 14. Okay, so that does not equal 7 times 6. This one has to be equal to 7 times 6. Oh, 6, that's a 6. And so that's what we're looking for. 5 plus 2 equals 7. The 6's are the same. In this case, we have 7 times 6 plus 1 times 6. That would be equal to 8 times 6, which is not what we're looking for. This one, it has our times 6 times 6, so that would be a 9 times 6, which is not what we're looking for. And in this case, our times 6's are the same, so we add 2 plus 5, which would equal to 7 times 6. Oh, Mrs. Sargent, there we go. And so we can mark that one as well. So these two expressions equal 7 times 6. Okay, I hope that helped with homework tonight. I won't make these videos every night, but when we have an especially tricky homework concept, I like to make sure that the kids have a explanation on how to do that. So I use these videos to help kids not complete their homework, but kind of understand their homework a little bit better. So I hope you enjoy it. Thank you very much.